Introduction to ellipse. An ellipse is a curved shape that resembles a straight circle, often seen in everyday objects like orbits or planets, racetrack, and even some agricultural design. An ellipse is defined as a set of all points where the sum of the distance from two fixed points called foci is constant.
There are three parts of an ellipse. Understanding the part of an ellipse is essential for analyzing its properties and writing its equation. Here are the key parts.
Principal axis of an ellipse refers to its major axis, which is the longest line segment that passes through the center and both foci of the ellipse. Vertices, the points where the ellipse intersects the major axis. These are the farthest points from the center. Co-vertices, the points where the ellipse intersects the minor axis. Foci, two fixed points inside the ellipse, located symmetrically along the major axis. The sum of distances from any point on the ellipse to the foci is constant.
So, in order to solve an ellipse centered at the origin, follow these steps. First, identify if your ellipse is horizontal or vertical. In order to determine if your ellipse is horizontal or vertical, you must look at your given. If your a squared is greater than your b squared, then it's horizontal. But if your a squared is less than b squared, then it's vertical. Step 2 is solving for your vertex, co-vertex, foci, and lactus rectum. In solving for your vertex and co-vertex, all you need to do is square root the given values. For foci, we have to square root the difference of a squared and b squared. And lastly, for our lactus rectum, we have to follow this equation, b squared over a squared. Okay, it's time for an example. By looking at this equation, x squared over 64 plus y squared over 36 is equal to 1, we can see that the a squared is greater than the b squared. So we'll be using this equation, meaning that this equation is an horizontal ellipse. So now, let's start by solving the vertex. So, a squared is equals to 64. What we need to do with this is we need to square root the a squared and the given value, which is 64. The square root of 64 is 8 and a. So meaning our vertex is 8. Now let's solve for our co-vertex. B squared is equals to 36, and same with the vertex, we square it. And we will get our co-vertex, which is 6. After solving for our vertex and co-vertex, let us now move to our foci. C is equals to the square root of a squared minus b squared. Let's substitute the given. A squared is 64, while b squared is 36. 46 46 minus 36 is equals to 28. After subtracting 64 and 36, we will now square root 28. The square root of 28 is 2 square root of 7 or 5.3. And lastly, for our lactus rectum, LR. LR equals to B squared over A. So our B squared, which is 36, this one, and our A, which is this, 8. 36 divided by 8 is equals to 4.5. After finding our vertex, co-vertex, foci, and lactus rectum, we will be using this as our vertex, this as our co-vertex, this as our foci, and lastly, this as our lactus rectum. Since we are done solving, it is time for us to graph our ellipse. Let's start by putting a vertex. Since our ellipse is horizontal, we have to put our vertex on the x-axis. So our vertex was 8, so let's start at the origin. 0, 1, 2, 3, 4, 5, 6, 7, 8. And the other side, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now our co-vertices, which was 6. Since it's co-vertices, let's go upwards in our y-axis. It was 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Wait, this is the wrong color. 1, 2, 3, 4, 5, 6. Yes, here. And also on the other side. 1, 2, 3, 4, 5, 6. Now for our foci. Which was 5.3. 1, 2, 3, 4, 5. So it's 5.3. So it's like almost in between them, like right over here. And also other side, 1, 2, 3, 4, 5. Like that. Since we're done plotting our vertex, co-vertex, and foci, it's time to put our lactus rectum. In our lactus rectum, we have to start counting from our foci, going upwards and downwards as well as the other side. So our lactus rectum was 4.5, so let's count. 1, 2, 3, 4, 5, so it's in between here. Now the other side. 1, 2, 3, 4, 5. 4. 1, 2, 3, 4. Next here. 1, 2, 3, 4. 1, 2, 3, 4. We're done with all of that. Now it's time to connect all of them, so we can make our ellipse. There. That is an ellipse. I'm sorry guys, I didn't notice you guys couldn't see the color yellow in the video, so I just put black on it. This is our lactose rectum. This one, this one, this one, and this one. And let's not forget about the center. Now let's put the label on our plots. Here is V1 or vertex 1, the other side will be vertex 2. This will be W1 or co-vertex 1, and this is co-vertex 2 or W2. This will be our foci F, foci 1 and foci 2. This will be LR1 or lactose rectum, LR1, LR2, LR3, LR4, and our center, our origin, 0, 0. Yes. Now that we have our ellipse, it is time to put the value of our V1, V2, W1, W2, F1, and F2. Or vertex 1, vertex 2, co-vertex 1 and 2, foci 1 and 2, and our LR1 to 4. Now, before we find the value of our here, we must follow this guideline. X will always be first, next Y in the right. X, then Y. So, in finding our V1, it's over here. So, it's in the X-axis. So, its Y is 0. Now, let's count from the origin to V1. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. And then the other side, also 8, but this time it's negative because it's going left. This is positive, positive, negative, negative. So, in our W1 or co-vertex 1, it's on the y-axis. So, its x is 0. Now let's count from origin to W1. 1, 2, 3, 4, 5, 6. So its y is 6. And for co-vertex vertex 2 is negative 6 because it's going down. It's negative. Now for our foci, it's also in the x-axis. So its y is 0. And since we're gonna count it, it's 1, 2, 3, 4, 5.3. So it's positive 5.3. And the other side is negative 5.3. Now, for our LR1, let's find out what the X is. So X is 1, 2, 3, 4, 5.3. 5.3. Next, its y is 1, 2, 3, 4.5. Okay, 4.5. Next, the LR2 is still positive 5.3, but now its y is negative 4.5. Now the other side, since it's in the left, it's negative, so it's negative 5.3, and the y is going up, so it's positive 4.5. Now the LR4 is both negative because it's going to the left and going down. Negative 5.3 and negative 4.5. And with that, we're finally done solving for our ellipse. Thank you. Our